back to Science Fantastic with Professor Michio Kaku. Every week on Science Fantastic, we explore the amazing world of science, cutting-edge issues which affect our life and our understanding of our role in the universe. And with us today, once again, is our favorite astronomer, Dr. Ken Croswell of Berkeley, author of a number of great books on astronomy, including Alchemy of the Heavens and Magnificent Mars. And today we're going to talk about the night sky. That's right. I tell my students one day, why don't you do something that you normally don't do? Look up. Don't look at the ground. Don't look at your feet. Don't think about the next final exam. Look up, and you'll see this whole universe of ours with a comet. Now, some people say that once in a lifetime, we are privileged to be able to see a comet lingering in the night sky. Well, if you missed Halley's Comet back in 1986, there's another comet gracing the evening sky called Neowise. And so we'll say a few things about where they come from, what they're made of, and what's all this fuss about the comet. And then the night sky, Venus, Jupiter, Saturn, Mercury. You'll have a grand slam of the night sky with binoculars, with a telescope. Not to mention the fact that three countries are setting their sights on Mars. The United Arab Emirates already successfully had a launch. The Chinese and NASA, not too far behind, will also launch space probes. And in February of next year, we could have a traffic jam around Mars. And then we'll say a few things about our sun. Did you know that we are still debating the precise composition of the sun? So we'll say a few things about Jupiter and our sun. What do we know about the two giants of the solar system? Well, anyway, once again, we have with us online Dr. Ken Croswell of Berkeley, author of a number of great books in astronomy, including Alchemy of the Heavens and Magnificent Mars. So, Ken, once again, glad you could be on Science Fantastic.
Glad to be here, Michio.
Okay, let's talk about comets. Maybe some people missed Halley's Comet back in the 1980s, perhaps the most famous comet to go across the night sky every 76 years. But there's a smaller comet now hovering in the night sky. Perhaps you'll see it near the constellation of the Big Dipper. So let's talk about it. So first of all, what is the difference between a meteor and a comet?
Well, a meteor is something that just lasts for a few seconds, and you really have to be watching. You have to be lucky to see that meteor. It flashes by as a particle of dust burns up in our atmosphere. A comet is very different, although there is a relationship between comets and meteors, which I'll mention in a moment. But a comet simply lingers in the sky. You can see it night after night after night. It's not something that just flashes by in an instant. So you mentioned the most famous comet of all, that's Halley's Comet. And Halley's Comet, however, was not a great comet when it last passed by the Earth in 1986, and that's because it passed so far from the Earth. It was not a very prominent sight, so no one should feel bad that they missed Halley's Comet in 1986. And for that matter, it's also going to pass far from the Earth in its next passage in 2061, so that's not going to be a good pass either. For most of us here in the northern hemisphere, the last two great comets occurred in the 1990s in two successive years. 1996 was Comet Hyakutake, followed by Comet Hale-Bopp in 1997. Those are both wonderful, wonderful comets. Now, the current comet is called Neowise, named for the spacecraft that discovered it. And it's not a great comet, but it's quite a nice comet, especially if you can observe it through binoculars. Ideally, getting away from city lights. Comets can look much better when you're out in the country than among city lights. But, yes, definitely some of the photographs I've seen of the comet have been very nice, but it's not terribly bright, so you really do have to know where to look. And as you pointed out, it's south of the Big Dipper, and the best time to look is shortly after sunset when it gets dark and look to the northwest. And ideally, you will have dark skies away from city lights. And let me mention the connection between comets and meteors. Comets, as they travel through space, sprinkle their orbit with dust particles. And if the Earth encounters those dust particles, we see a meteor shower. So, for example, every August, we see the Perseid meteor shower, and those Perseid meteors are the gift of a comet called Swift-Tuttle, named for the two astronomers that discovered it. So there is a connection between comets and meteors, but comets are much easier to see in the sense that they don't just flash by in an instant. You can see them night after night after night.
Okay, well, speaking of Hale-Bopp comet, I still remember seeing it sailing over Manhattan, over Broadway. In spite of all the lights of Manhattan, you could actually see the Hale-Bopp comet sail over Broadway, which was quite a sight when I saw it myself. Well, this comet, Neowise, is going to return in 6,800 years. So if you missed it, you have a second chance to catch it on this next flyby 6,800 years from now. So then the next question is, well, where does it go for 6,800 years? Where do comets come from anyway? They've, of course, been the source of much speculation over millennia, but we now know. So where do comets come from anyway?
The comets, such as Neowise, came from the Oort cloud, which is located far beyond the orbits of Neptune and Pluto. These comets, we think, actually started off in the protoplanetary disk that gave birth to the solar system, that is, the planets of our solar system. And then the giant planets, through their gravity, kicked those objects either out of the solar system altogether or into the Oort cloud, and they remain bound, gravitationally bound to the sun. They orbit around the sun. You mentioned that Neowise goes around every 6,800 years, and so at their farthest point, they're really far out. I mean, there are comets that are more than a light year from the sun, and so every now and then one of these comets falls toward the sun on its highly elliptical orbit, passes by the Earth, and passes near the sun with the sun's heat, vaporizes some of the ice, and we see a nice, beautiful tail, and that's exactly what's going on now with Comet Neowise.
And speaking of that, I think it was Johann Kepler who finally figured out where the tail of a comet comes from and which direction it points, because most people think that the tail of a comet is like the exhaust of a rocket, but that's not really true, right?
That's right. It always points directly away from the sun, because it's the solar wind that blows the departing material away from the comet. So you cannot actually look at the tail and say, yes, it's going in that direction. It may be going some completely different direction. All the tail tells you is where the sun is. So, for example, if you look at Comet Neowise after sunset, the tail is pointing away from the sun, which at that time of the night will be beneath the horizon, beneath the western horizon.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, our special guest today is once again astronomer Ken Croswell, author of the book Alchemy of the Heavens and Magnificent Mars, and we're talking about the night sky. Look up, and perhaps you'll see in the direction of the Big Dipper a comet, Comet Neowise. And as I understand, throughout human history, people have been fascinated by comets because they linger, not just for seconds, but for days, weeks in the night sky. Some people think they foretell the death of the king, and in 1066, a comet sailed over the battlefield of Hastings in England, and it spooked out the troops of King Harold, heralding the victory of William the Conqueror. So some people think that Halley's Comet, which sailed over England in 1066, in some sense spooked the troops of King Harold, paving the way for the modern British monarchy. So in some sense, maybe modern England is the way it is because of a comet. So, Ken, comets, what are they made of now? We talked a little bit about ice, but how do they differ from the composition of meteors and asteroids?
Well, comets are described by the so-called dirty snowball model. And this is a model that was proposed in the early 1950s by Harvard astronomer Fred Whipple. He said that they consist of rock and a good deal of water ice. And as one of these objects nears the sun, it heats up and some of the water ice vaporizes and pushes off gas and dust, and that's what accounts for that beautiful tail that you see in a comet. And then, of course, if the Earth runs into the particles that the comet has shed, then we see a meteor shower when those particles enter our atmosphere and burn up in the atmosphere.
Okay, and finally, what is the difference between asteroids and comets in terms of where they are located in the solar system and what they're made of?
Well, the comets come from far away, whereas most of the asteroids in our solar system are located closer to the sun, most of them between the orbits of Mars and Jupiter. And asteroids are rocky objects. Now, that doesn't mean they can't contain water ice. In fact, the largest asteroid series does contain water ice. But comets are just much more, I guess you could say, much more glamorous objects, much more flamboyant objects, much more beautiful objects, because they come close to the sun, and the heat of the sun gives birth to their long tails. Asteroids are, shall we say, duller objects. But both asteroids and comets represent leftover building blocks from the formation of the planets of our solar system, and that's one reason that astronomers like to study them, is because both asteroids and comets give clues to how the solar system arose.
Well, every Hollywood scriptwriter wants to know about how dangerous they are. Can we have a comet hit the Earth? Now, some people say that comets that we track are periodic. That is, you wait long enough, they come back in an elliptical orbit, and you can predict the next cycle. But some comets way out there in the Oort cloud, as you mentioned, could be non-periodic. That is, make just one pass through the solar system and catch us totally off guard. In fact, if one such comet went behind the sun, we wouldn't have any notice until it came away from the sun, and then we would only have a few weeks warning before it hit the Earth. So tell us a little bit about the fact that, well, we're not going to be hit by a comet anytime soon, but non-periodic comets, comets that are non-periodic, we don't know when they're going to come back, do they pose a potential danger?
Well, yes, they do, and so do asteroids, for that matter. Any such a very large impact could wipe out an enormous amount of life on Earth. That's what happened 66 million years ago when the dinosaurs went extinct. An asteroid hit the Earth measuring maybe 10 miles across. About 6 miles across, 10 kilometers across. Now, you mentioned the possibility that there are these very long period comets. I don't think any comet in the Oort cloud is non-periodic, just that over a human lifetime, of course, we're not going to see that comet come back twice. But if we could wait millions of years, then we would actually see the same comet come back twice. The so-called periodic comets are the ones that we do see coming back repeatedly. So, for example, the most famous comet, Halley's Comet, returns every 76 years. We last saw it in 1986. We'll see it again in 2061. And we can count on seeing it again in the 22nd century. So, yes, some comets we see repeatedly and others we just see once because their orbital periods are so very long, like near-wide.
Now, I understand that we have photographed the nucleus of Halley's Comet back in the 1980s, and the nucleus is about 20 miles across, about the size of Manhattan, and it's shaped like a peanut. It looks like two globs have been fused together to create a comet nucleus, which means that perhaps in the future, Halley's Comet may split apart into two pieces. So isn't it true that comets are sometimes unstable? Sometimes they hit the sun. Sometimes they split apart. Halley's Comet has been stable for thousands of years, but perhaps in the future it too will break apart. What are your thoughts?
Well, Halley's Comet is actually not quite as big as you said. It's more like 5 or 10 miles across. But you're absolutely right. We've observed comets split apart. For example, there was a comet in the 1800s called Biela's Comet that split into two as we were observing it. And the reason for that is almost certainly because of the stress put on the comet by the intense sunlight as the comet nears the sun and heats up. So, yes, we do see comets splitting up. They're not the most stable of bodies. They're not as stable as asteroids are. So comets can indeed break up, and indeed some of the comets that have hit Earth in the past and the Moon in the past probably have been pairs of comets that broke up as they just before they hit the Earth and the Moon.
Right, and as I understand, there was this monstrous meteor shower as the Earth went through the tail of a comet back in the 1800s. It was so astounding that it created religious groups. Doomsday cults came out as a consequence. And the Jehovah's Witnesses, Seventh-day Adventists, some religious organizations can actually trace their lineage all the way back to the great meteor shower of the 1800s. So meteors and meteor showers and comets also affect human history as well. Well, let's say a few things now about the night sky. Let's say you're a kid and you want to get a telescope or binoculars. First of all, what would you recommend for a beginner that wants to take a look at the night sky and see the rings of Saturn and take a look at what we have in our solar system? What would you suggest?
I would actually suggest getting a pair of binoculars first before you get a telescope and explore the night sky with binoculars, because binoculars are cheap. They're very easy to handle. They don't weigh a whole bunch. They're not, then you may already have them, but that's a great way to explore the night sky. You won't be able to see the rings of Saturn with a pair of binoculars, but you will be able to see, for example, star clusters like the Pleiades. It's a beautiful star cluster. You can see it with the naked eye, but it looks absolutely stunning through a pair of binoculars. As far as things to see, I mean, Venus is a beautiful planet that is visible right now before sunrise in the east. You can also see Jupiter, which is rising in the southeast a few hours after sunset. And in fact, let me correct myself on that. Jupiter is rising right around sunset because Jupiter is right now at opposition, along with Saturn. Jupiter and Saturn are right now together in the evening sky, and they'll be rising around sunset in the southeast. So those are some of the bright objects, easy to see objects that anyone should be able to find: Venus, Jupiter, and Saturn.
Now, children say the nursery rhyme, "Starlight, star bright, first star I see tonight." Isn't it true that chances are that's not really a star that children see at all, but it's really the planet Venus, which is the brightest object other than the moon? So isn't it possible that many people confuse Venus for a star?
Yes, and also Jupiter. Jupiter is also incredibly bright. In fact, the first star you see tonight probably will be Jupiter, since it's so much brighter than any star. Venus right now is in the morning sky, so it's definitely not going to be visible tonight.
Welcome back to Science Fantastic with Professor Michio Kaku. Today we're talking about the night sky. Let's do something that most people hardly ever do, and that is look up. That's right, look up. Don't look at the ground. Don't look at your feet. Don't mull over all the things you have to do today. Look up. Look at the night sky. Look for Venus. Look for Jupiter. Look for Mars. Look for this glorious solar system that we inhabit. And with us to guide us is astronomer Ken Croswell of Berkeley, author of Alchemy of the Heavens. Where we last left off, we were talking about some of the planets that you could see, like with the naked eye, Venus and Jupiter. However, I remember getting my first telescope. It was about a 3 or 4 inch reflector telescope, and I saw the rings of Saturn for the first time. And it was almost like an existential shock. I mean, this is better than any science fiction movie, because you know that this is reality, that there it is hovering above you, the rings of Saturn. So, Ken, tell us, if you are an astronomer that wants to know a little bit more about the universe and you're finished with the binoculars, what's the next step beyond the binoculars that will reveal the rings of Saturn?
And that would be a small telescope. And indeed, a small telescope can see the rings of Saturn, which are very impressive. There are other planets in our solar system, including Jupiter, Uranus, and Neptune, all of which have rings too, but none compare to the rings of Saturn. Saturn's rings are absolutely stunning. And it's a question, it's an open question, a scientific question, how common are such beautiful planets in our universe? We don't know. We know that giant planets are quite common, but how many of them have such stunning rings the way Saturn does? We just don't know. But yes, the next step up after you explore the night sky with binoculars, and if you're still into doing astronomy, the next step up would be to get a telescope, maybe a 6-inch, an 8-inch telescope would definitely reveal the rings of Saturn.
And not to mention the fact that your cell phone allowed you to project the night sky right in front of you. You just look at the direction of north, and some cell phones already know the direction of north. And from that, you can see the whole night sky with all the stars with their names listed for you right there on your cell phone. So the planets, when you look at the arrangement of the planets, when you look at the entire night sky, don't they follow into a line, a plane, the ecliptic plane? So in some sense, you can actually trace the location of the planets by looking for the disk, the plane of the solar system, right?
That's right. So, for example, right now, Jupiter and Saturn are very close together east of the constellation Sagittarius, and they would make a line with the sun. If you could imagine an imaginary line extending all the way to the west, beneath the horizon to where the sun is, and also the moon follows that same line. And that more or less, because all the planets, with the exception of Eris, are more or less in the same plane. Even Pluto, by the way, is pretty close to that plane. It's not exactly in it, but the planets form from a disk of gas and dust, a flat disk of gas and dust, and that's why most of them are still more or less near that plane to this day.
And also, when I look for Venus, I look in the direction of the sun because Venus is closer to the sun than the Earth. So when the sun sets, I can see Venus. But Mercury is very close to the sun, and I've never seen it. I've never seen Mercury. I guess you would have to time it very carefully. When the sun goes down, you then look for this bright object in the night sky. So what is the best way if you want to see Mercury, given the fact that it's close to the sun? Welcome back to Science Fantastic with Professor Michio Kaku. Once again, with us on the line is astronomer Ken Croswell of Berkeley, author of a number of great books, including Alchemy of the Heavens, Magnificent Mars, The Universe at Midnight. And if you want to know more about Science Fantastic, go to my website, mkaku.org, mkaku.org. On Facebook, we have about 3 million fans on Facebook. And I've written 4 New York Times bestsellers that are listed on my website. Well, let's talk about the night sky. We mentioned the fact that once you graduate from binoculars, you may want to get a small reflecting telescope. I've seen with the naked eye Venus, Jupiter, Saturn, but Mercury I've never seen because apparently it's quite difficult to see it because it's very close to the sun. So are there any tricks by which you can see the planet Mercury at sunset?
Yeah, Mercury is really difficult to see. I've only seen it maybe 4 times in my entire life. And you're right, you have to time it just right. You can only see it either low in the western sky right after sunset or low in the eastern sky right before sunrise. And right now, Mercury is visible right before sunrise in the eastern sky, but you have to time it right. And the reason it's so hard to see is because even though Mercury is a fairly bright planet, you're looking for that fairly bright planet against the sky that is also quite bright. You're looking for that planet against the dawn sky, and so there's a lot of light. It's not nearly as easy as something like Jupiter or Saturn. Jupiter and Saturn you can see against a very dark sky. So Mercury is a challenge. You do have to time it right. Right now, here in July, it turns out that Mercury is visible in the eastern sky before sunrise, but you have to have an unobstructed view to your east in order to see it, and you have to get up pretty early in order to see it right now. So, as I say, I've only seen it maybe 4 times in my life, so don't feel too bad if you've never seen the planet Mercury. It's hard to see, and by the way, historically, we didn't know much about Mercury until we sent a spacecraft there. in 1975 because it was very hard to observe the planet from Earth.
Okay, and moving on, there's the planet Mars. Now, people may be disappointed when they buy their telescope. They want to see the canals of Mars. First of all, Mars has no canals. Second, it's very small. It is red because of rust, but you cannot see surface features unless you have a much larger telescope. Sorry about that. However, 3 countries are aiming for the red planet. The United Arab Emirates had a successful launch. The Chinese are going to follow that up, and then the United States will launch its probe shortly afterwards. So we're going to have a traffic jam around Mars, and NASA is going to put a helicopter on Mars, and rock retrieval is on the agenda as well. So do you have a few words to say about what's new about the recent missions planned for Mars with helicopters and rock retrieval?
Well, the NASA mission will be quite interesting. It's called Perseverance, and it's going to land, if all goes well, on February 18th of 2021. That just happens to be the anniversary of the discovery of the planet Pluto. And Mars and Pluto actually have a connection because Percival Lowell opened an observatory to study the planet Mars, but during his life he led a secret search for a 9th planet, which after his death resulted in the discovery of the planet Pluto. Perseverance is a very large rover, and it weighs over 2,000 pounds, okay? So it's going to do a lot. It's going to carry a very small helicopter, as you mentioned. It's just kind of an experiment to see if that will work on Mars in the very thin Martian atmosphere.
Okay, and rock retrieval. Tell us a little bit about the fact that we actually already have rocks from Mars on the planet Earth. Think about that. Rocks from Mars, perhaps maybe in your backyard. So how do we know that Martian rocks have actually landed on the Earth?
Well, we look at the isotopic ratios of gases in those rocks, and they match those of the Martian atmosphere. They're meteorites that have come from Mars. They used to be rocks on the surface of Mars, and something hit Mars, blasted those rocks into space, and those rocks then drifted through space and eventually encountered the Earth, and we found them. Now, of course, most meteorites do not come from Mars. They come from elsewhere, but a few do come from Mars.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, with us on the line is astronomer Ken Croswell of Berkeley, author of a number of great books, including Alchemy of the Heavens. And today we're talking about, well, the night sky, our own backyard. If you haven't, go outside, look up, see the fact that there could be a comet lingering in the direction of the Big Dipper, and realize that there's a whole solar system out there waiting to be discovered. Venus, the brightest object in the night sky other than the moon, can be seen, not to mention Jupiter, Saturn, Mercury, and Mars is in the target of several nations. We have the United Arab Emirates, the Chinese, and the United States all gunning for Mars. And in February of next year, there could even be a traffic jam as we have all these space probes reaching the red planet. In fact, every 26 months, we have a window of opportunity. It's no accident that we have these probes being launched within days of each other, and not to outdo each other, but it's simply a question of aeronautics. We have a window of opportunity where the shortest distance between us and Mars by rocket is by going through this window every 26 years. So Mars is on the agenda. But there's some mysteries which are still lingering. For example, what is the sun made of anyway? You know, Auguste Comte, the great French philosopher, once made a challenge to the world of astronomy and physics. He challenged physicists around the world. He said that science will know many things about the world, but there's one thing that we will never, ever know, and that is what the planets and what the stars are made of. Well, just a few years after Auguste Comte made that challenge, physicists said, hydrogen. it's made out of hydrogen because they looked at the spectral lines, shot the lines through a prism, and they found a fingerprint of the spectral lines of hydrogen and a mystery mineral that they called helium. They thought it was a mineral. And helium was first found in the sun by looking at starlight. So Ken, right now, as I understand, there's yet another controversy as we get finer and finer understanding of what the sun is made of. So explain to us the latest controversy.
Yes, this has been going on for the last 20 years. We don't know exactly what the sun is made of. We do know, as you just said, that it's made mostly of hydrogen and helium, which are the two most common elements in the universe, and the two lightest elements as well. But then we are really confused. We don't know how abundant the next most abundant elements are. Those are oxygen, carbon, neon, and nitrogen. Three of those four elements, of course, are very important for life. Oxygen, we breathe it. Carbon, life is based on it. Nitrogen is part of protein. And the reason this is so very important is because we astronomers use the sun as our standard for elemental abundances throughout the universe. So if we don't know what the sun is made of, we don't know what the other stars are made of, and we don't know what the entire universe is made of. And I recently wrote about this problem at Knowable Magazine. You can go to knowablemagazine.org and read all about it. It's called An Elemental Problem with the Sun. And astronomers are loggerheads over this. They do not know. There are two different methods for determining the composition of the sun, and they give two different answers. One gives a 42% lower abundance of oxygen than the other. And so we just don't know what the sun is made of in terms of how much oxygen it has relative to hydrogen, how much carbon it has relative to hydrogen, how much nitrogen it has relative to hydrogen. Now, the good news is there are experiments ongoing that we hope will answer this question in the next 10 years. And in fact, just recently, you may have heard that there was the detection of neutrinos from the CNO cycle in the sun. The CNO cycle involves carbon, nitrogen, and oxygen. And the hope is that as we measure more and more of those neutrinos, those will tell us just how much carbon, nitrogen, and oxygen the sun has, and thus resolve this controversy. So if you want to read more about that, you can just go to the Knowable Magazine website and look for An Elemental Problem with the Sun.
Okay, well, back in the 1800s, Fraunhofer, the one who first found out what the sun is made of, took starlight and sunlight, put it through a prism, and by looking at the spectral lines, you have a fingerprint of different elements like hydrogen, helium, and stuff like that. And he said, aha, I see the spectral lines of hydrogen. But that doesn't give you the composition of the entire sun. It just gives you the composition of the surface of the sun in terms of starlight. So you mentioned a second method. What is the second method by which we determine the composition of the sun other than looking at starlight?
Well, it turns out that the sun vibrates just as the Earth vibrates. On Earth, we call those vibrations earthquakes. They're not the most pleasant things, especially if there is a strong earthquake. But geologists use those to probe the interior of the Earth. Likewise, astronomers use the vibrations of the sun to probe the inside of the sun. And it turns out that those measurements can tell you a lot about the inside of the sun. And the exact structure of the solar interior depends on how much oxygen and other heavy elements the sun has. So that's the other method for determining how much oxygen the sun has. And those measurements of the interior give you a higher number for the number of oxygen atoms in the sun than does the first method, in which you look at the sunlight and analyze, well, okay, how many oxygen atoms are there relative to hydrogen? And so, as I say, the hope is we'll be able to resolve this matter in the next 10 years. But for the past 2 decades, we've been arguing about it, and we just don't know who's right.
Okay. Well, unfortunately, we have run out of time. Once again, our special guest has been Dr. Ken Croswell, author of the book Alchemy of the Heavens. So, Ken, once again, thank you so much for being on Science Fantastic.
Oh, you're very welcome.